for example 4, we're given a sequence. We can see what the first term is. Let's write the formula starting with a sub 1 is 12, which simply says the first term is 12. And now a sub n, any term, is a sub n minus 1, the previous term. Then we have to figure out how are we getting from one to the next. Well, I don't even, like, with all these decimals, I don't think I want to even consider could it be geometric. Maybe it is, but I don't think I want to go down that route first. Well, to get from 12 to 13, I add 1, but that's 0.2. So I'm thinking maybe I add 1.2. Well, if I add 1.2 to 13.2, I'll get 14.4. So, hey, that's the same. And I see again, if I add 1.2, that I get to 15.6. So that I can see I have a constant difference, which is 1.2, which is telling me any term is the previous term plus 1.2. There's your recursive formula for this. Hey, just for additional review, I want to write the explicit formula for this. So this was the recursive formula for that. I'm curious, can we write the explicit formula? Well, explicit formula, we'll start with any term is the first term in that sequence is 12, and now it's growing through constant addition, so we're going to write plus, we're going to write that amount that's being added, 1.2, and then to account for repeatedly adding 1.2. Repeated addition of 1.2 would be expressed as multiplication, so we're going to multiply it by n minus 1. Now this n minus 1 doesn't mean the previous term. A sub n minus 1 means the previous term. This means the position in the sequence. So if you wanted to see if this formula works, you could pick any term in the sequence. You could pick maybe the third term. That tells you n is 3. And you could put 3 into this formula. 3 minus 1 is 2. 2 times 1.2 is 2.4. 2.4 added onto 12 is 14.4. So be careful, because sometimes people start thinking anytime you see n minus 1 it means the previous term. It's only the previous term if it's a subscript of a variable. So watch out for that. Recursive, explicit. Now, this next one. Oh my God, look at all those fractions. Well, fortunately all the denominators are still 11. Well, now let me look at the numerators. 103 to 100 to 97 to 94 to 91. It seems like we're subtracting 3. We are subtracting 3 from the numerator. So be careful. If you're like, the constant difference is minus 3. Wrong. You have to remember that denominator, when you're adding or subtracting fractions, if the denominators are the same, you can combine the numerators. So you have to realize that 103 elevenths minus 3 elevenths gets you 100 elevenths. And you have to remember 100 elevenths minus 3 elevenths gets you 97 elevenths. So the constant difference isn't negative 3. The constant difference is negative 3 elevenths. So now that we have that squared away, we can write the recursive formula for this. We'll say the first term is 103 elevenths, and the new term is the previous term, take away 3 elevenths. There you have it. Now, this last example right here, this one looks annoying. Because, okay, maybe you just started making some sense of what we do when we see a sequence given. And now, I didn't give you a sequence, I gave you a formula. Do you remember what that type of formula is called? Explicit. I gave you an explicit formula, and I want you to write the recursive formula for it. Well, if you look back to what I happened to do in example 4, and I gave you this, or we wrote this explicit formula for this sequence, maybe you see that if we're constantly adding 1.2, we see plus 1.2 times n minus 1. So looking at that, we could see, hey, I see plus 2 times n.1. Maybe that means I'm adding 2 every time. It does. Your constant difference for this is 2. And hey, when I look at this, that 12, that was the first term in the sequence. Maybe the first term in the sequence is 98. It is 98. So this one, you can say, because it's written in the general setup for explicit formulas, you can consider that to be the first term, and this to be the constant difference of positive 2. Well, if you've got that information, you've got the information that's used in a recursive formula. It tells you what the first term is, and then you see what that constant difference is. So you could just jump to saying the formula for this is the first term is 98, and the new term is the previous term plus 2. That's it. If you're having doubts, if you're suspicious that seems a little bit too convenient, okay, you could build the sequence. You could say, well, I want to see what this sequence looks like written out. So let's write out a few terms. So the first term happens when n is 1. Well, let's let n be 1. 1 minus 1 is 0. 0 times 2 is 0. 0 plus 98. The first term is 98, which verifies that we're correct that the first term is 98. The second term happens when n is 2. So if I put 2 in here, 2 minus 1 is 1. 1 times 2 is 2. 2 plus 98 is 100. And let's get the third term. So n is 3 for the third term. 3 minus 1 is 2. 2 times 2 is 4. 4 plus 98 is 102. And I think by seeing just these first three, you can see how you go from 98 to 100 and how you go from 100 to 102. And you get there by, adding 2, which verifies that yes, that constant difference is 2. So the first term is 98, the new term is the old term plus 2.